In this lecture, we solve the question based on the complex number. So the question is, if z minus 1 upon z plus I is purely imaginary, find the locus of z. So let z is equal to x plus iy. Then consider z minus 1 upon z plus I. So let us replace z by x plus iy minus 1 upon x plus iy plus I. Now let us write down this x minus 1 first, real part, and then plus iy. Similarly, this is real part is x and in imaginary part iy plus I. So we have taken I common. So we have I times of y plus 1. Now, this is the complex number. So we have to realize it. We have to convert the denominator in the real number. So we have to multiply and divide by its complex conjugate. So complex conjugate of x plus I times of y plus 1 is nothing but x minus I times of y plus 1. So we can write down x minus 1 plus iy upon x plus I times of y plus 1 multiplied by x minus I times of y plus 1 whole divided by x minus I times of y plus 1 by realization. So we are multiplying and divide by its complex conjugate of the denominator. Let us try to multiply. So now if we solve this x minus 1 whole multiply with this part, x minus 1 into x minus I times of y plus 1 plus this multiply by again this. So plus iy times of x minus I times of y plus 1 and whole divided by it is a plus b and it is a minus b. So it is nothing but a square minus b square. Okay, so now let us go ahead and try to simplify it. So x minus 1 into x is x into x minus 1 minus I times of x minus 1 plus y plus 1 and then plus I of xy minus this I into I square whole times of y into y plus 1 whole divided by x square minus I whole square I square plus y plus 1 whole square. Again, let us simplify again this part. So x into x minus 1 is nothing but x square minus x, then minus I we have taken outside. So x into y is xy, then plus x minus 1 into y is minus y, and minus 1 plus 1 is again minus 1. Plus I of xy minus I square is plus 1. So we are only taking 1 because I square is minus 1. So minus into minus will become plus. And again y into y plus 1 is y square plus y. And the denominator again x square. This I square is minus 1. So minus 1 into minus will become plus into y plus 1 whole square. Now here this minus x I xy, this is plus I xy. So they both will cancel. And now let us try to write down the real part first. X square minus x plus y square plus y. This is the real part. So x square plus y minus x and minus of x minus y minus 1 whole divided by x square plus y plus 1 whole square is y square plus 2y plus 1 square is 1. So z minus 1 upon z plus I, which is equal to x square plus y minus x minus I times of x minus y minus 1 upon x square plus y square plus 2y plus 1. Clearly, here we can separate the real and imaginary part. So real part is x square plus y minus x whole divided by x square plus y square plus 2i plus 1. This is the real part. And minus of I times of x minus y minus 1 upon x square plus y square plus 2i plus 1 is the imaginary part. So since the given expression, this z minus 1 upon z minus z plus I is purely imaginary, so its real part will be zeros, because if we know that if any complex number is purely imaginary, it means that their real part will be zero. So the real part of this complex number is this. So let us equate this equal to 0. Means x square plus y square plus y minus x upon x square plus y square plus 2i plus 1 equal to 0. So we can write down this is 0 by 1. So let us do the cross multiplication, this into this and this into this. So we have x square plus y square plus y minus x, which is equal to 0. Now, since the coefficient of x square and coefficient of y square is 1, so it is nothing but a equation of circle. So let us try to write down in the standard equation of circle. So what we are doing over here, let us first write down x square minus x and plus 1 by 4 we are adding in the left hand side and also in the right hand side. Similarly, there is a y square plus y plus 1 by 4 we are adding in the left hand side, so we have to also add in the same number in the right hand side. Now it can be written as x square minus of 2 into 1 by 2 into x plus 1 by 4 can be written as 1 by 2 whole square. So here it is x square minus 2 into 1 upon 2 into x plus 1 upon 2 whole square. So this is nothing but x a minus b whole square, means x minus 1 by 2 whole square. Similarly, if we take the second part, y square plus 2 times of 1 by 2 into y plus 1 by 2 whole square, and this for 1 by 4 plus 1 by 4 is 2 by 4. So this is equation of this can be written as x minus 1 by 2 whole square, and this can be written as x plus 2 y plus 1 by 2 whole square, which is equal to, this is 1 by 2, so 1 by 2 is 1 upon root 2 whole square. So this is x minus a whole square plus y minus b whole square, which is equal to radius square, is nothing but a equation of circle. So which is a circle with center 1 by 2 minus 1 by 2 and radius is 1 upon root 2. So this is the circle whose center is 1 by 2, a circle like this, whose center is 1 by 2 and minus 1 by 2, and radius is 1 upon root 2. This radius is 1 upon root 2. Thank you.